Hi, this is the Masking Handbook for Audiometry. In this video, we'll be looking at some issues connected with unmasked bone conduction testing. As we know, unmasked bone conduction testing is not ear-specific. When we measure an unmasked bone conduction threshold, we really don't know which ear it's coming from. Sometimes we infer which ear it may be coming from, but that's different than completing ear-specific measurements. Also, there are times when we might not care which ear the unmasked bone conduction results are coming from. So we're going to look at some of those issues by considering a few cases. And just a caveat for this discussion, we're going to use 0 dB as our theoretical intraoral attenuation value for bone conduction testing. In this first case, we have an asymmetrical hearing loss, and there are some unmasked bone conduction threshold results documented on the left side. So that suggests that the bone conductor was placed on the left mastoid for those results. They're unmasked, so we really don't know which ear those unmasked bone conduction thresholds are coming from. Now, the unmasked bone line is not showing any air bone gaps from the left ear. When we see those results connected to the overall air conduction hearing of the left ear, we're allowed to not care which ear they're coming from. We've ruled out any conductive components in the hearing of the left ear. So in this situation, even though we have unmasked bone conduction results measured and we don't know which ear they're coming from, we can still consider our view of the left ear to be fairly complete. In other words, we can infer that there's a sensory neural hearing loss on the left side, and we can rule out any conductive components there. However, these unmasked bone conduction results may be coming from the right side. They may be coming from the right cochlea. Even if that's the case, it means that the left ear would have either equal or poorer bone conduction hearing than the right ear. So either way, they may be coming from the left side, they may be coming from the right. We identify that the left ear has a sensory neural hearing loss either way. We don't know the status of the right ear at all at this point. We'd need to do masked bone conduction on the right side to find that out. Let's take a look at a second case. We do care about which ear these bone conduction results are coming from, but we have no idea which side they are coming from. You see there's a fairly symmetrical, kind of mild to moderate hearing loss. Unmasked bone conduction results were completed with the bone conductor placed on the left side. In this situation, we know that one of the ears has a conductive hearing loss at each particular frequency, but would need to complete masked bone conduction testing to determine the nature of the hearing loss in each ear. So in this situation, we don't know which ear has the conductive hearing loss at each frequency. We know that one of them does. We can't really infer any ear-specific conclusions. Let's take a look at this third case. It's a very similar degree of hearing loss. We've got a mild to moderate symmetrical hearing loss in each ear, and we've got unmasked bone conduction testing done with the bone conductor placed on the left mastoid. Similar to the previous case, we have no idea which ear these results are coming from. So it could be the right, could be the left, it could be a combination of the two depending on the frequency. Unlike the previous case, we can make an inference about the nature of the hearing loss here. If we apply each unmasked bone conduction threshold to each air conduction threshold on either side, there are no air bone gaps present. So we can conclude or infer a sensory neural hearing loss on each side, even if we don't know which ear heard each specific bone conduction threshold. We've ruled out air bone gaps at each frequency from both ears. In this instance, we don't care which ear has heard the unmasked bone conduction signal. We just know that there's no air bone gap indicated on either side. Given what we know about real bone conduction intraoral attenuation, however, it's possible that if we put the device on the right mastoid and retested bone conduction, we might get something like this. This is the problem with using 0 dB as our min IA for bone conduction testing. It does streamline the process for us, but on occasion it may not match reality. However, if you have normal tympanograms and present acoustic reflexes showing normal middle ear function, it's reasonable to accept the unmasked bone conduction results from one side. Middle ear testing, along with our behavioral audiometry, provides a full picture of the situation in that case. Let's take a look at a fourth case. You might see these results and think, why didn't they do more testing? But if I told you these results were from a 2-year-old, you'd think, wow, these people were great at testing kids. Sometimes the situation determines how much information you can collect. In this case, it's impossible to do masked bone conduction testing because of the child's age. We know that at least one ear has a conductive hearing loss, but we don't know which ear. We could say something like, this child has a conductive hearing loss in at least one ear. In these cases, again, our acoustic emittance testing can be helpful in determining what's going on. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.